Hello, everyone. In this video, we're going to be graphing a couple of functions using transformations. So let's just jump right into it. So when graphing any function using any transformations, the first thing you want to do is to start off with your base function. So what function are you going to be doing the transformation on? And in this case, it'll be the absolute value function. So I'm just going to label it g of x, and it's going to be the absolute value of x. In your text, you have the different functions that you'll be doing transformations on. Um, for example, you have f of x equals the square root of x, f of x equals um, x cubed, f of x equals x squared, and so on. You have one of them will be the absolute value of x. So I chose this one for my base function because our original problem has absolute value symbols in it, so the base function is the absolute value of x. And then with each function, you need to identify some key points. So some key points to go with this base function would be, I would choose -1, 0, and 1, just small, easy numbers. In your textbook, they also have some key points to go with each, along with the shape of the graph. So if we take g of -1, that would be the absolute value of -1, which is 1, and g of 0 is the absolute value of 0, 0, and g of 1 is the absolute value of 1, which is 1. Okay, and then so the next thing I like to do is just to rewrite the function that I'm actually going to have to graph over to the right. And of course, I'll need some points to go with that. And then in the middle, I'm going to write the arithmetic that will allow me to do my transformation on the absolute value of x. So let's look at our x values. From this x value to this x value, what is different about it? How did it change? And we're looking at the arithmetic that is being done to the x. So here we're subtracting 1. Well, we actually do the opposite or the reverse operation to x. So for subtracting 1, we're going to say we're going to be adding 1 to our x values. And there is a reason for that, and I can explain that in another video. But you just do the opposite operation to your x. Now, y is the absolute value of x, right? G of x is just another notation for y. So y is this. So now this y, what are we doing to it? What's different from here to here? We're actually adding 2 to y. So to the y, we're adding 2. So to the y value, you just do whatever operation's being done. If you're subtracting 2, you subtract 2. If you're adding 2, you're adding 2, and so on. Okay, so now we're going to do this arithmetic on these points so I can get my new points. All right, so to all our x values, we're going to add 1. So -1 plus 1 is 0, 0 plus 1 is 1, and 1 plus 1 is 2. And then to all the y values, we'll add 2. 1 plus 2 is 3, 0 plus 2 is 2, and 1 plus 2 is 3. And then we'll go ahead and plot these on our graph. So we have 0, 3, 1, 2, and 2, 3. And so we know the absolute value, when we connect the dots for the absolute value function, it connects like a V shape. Okay, so you're done. That is it. That is how you graph this absolute value function using transformations, and you do that with any function. So if we go back and name these transformations that we did. So let's look at our original. So we have -1, -1, 0, 0, and 1, 1. And if you look at the x value from here to here, we subtracted 1, which is actually a horizontal shift to the right 1. So we took this graph and we shifted everything right 1. Now, if you follow the origin, you can easily see that. So we go over here and write 1, but then we took all our y values and added 2. So we shifted up 2. So we go right 1, and we did a vertical shift up 1, 2. So now our origin landed at 1, 2 right here. And of course, we're shifting all the points. So that is the graph for this function using transformations. And now I will graph the square root function using transformations. So again, we identify the base function, okay? So I'm going to call it g of x, and that will be the square root of x. Because again, we want to see which one of our functions listed in our textbook looks like the one that we're given. And clearly it would be the square root function because we have the square root symbol in the original. Right, so like, again, you'll have the different functions listed. So for example, f of x equals 1 over x, f of x equals the cube root of x, and so on. But we have the square root of x. Okay, and then you want to identify some key points to go with that. I'll choose 0, 1, and 4. These are also given to you, but you can just pick the just small, easy numbers. So g of 0 would be the square root of 0, which is 0. And g of 1 is the square root of 1, which is 1. And g of 4 is the square root of 4, which is 2. So again, when you're taking the square root of a number, you're trying to find the natural number that you would multiply to itself to get the radicand, the number under the radical sign. So the square root of 4 would be what number times itself, what whole number times itself would be 4, and that would be 2, right? 2 times 2 is 4. Okay, and then the next step I like to take is, again, just to rewrite the function that I'm actually going to graph and put some points to go with that. Okay, so now let's do arithmetic here that will write arithmetic here that will allow us to do the transformation on these points on this graph. So if I look at the x from here to here, the difference is I'm adding 2, but we always do the opposite operation. We're going to subtract 2, and then y is the square root of x, so bringing that y over here. So from this y to this y, I subtract 1, and you always write down whatever, as is, whatever the arithmetic that you see that's happening to y. So we're going to do all this arithmetic to these points. So 0 minus 2 is negative 2. 1 minus 2 is negative 1. 4 minus 2 is 2. 0 minus 1 is negative 1. 1 minus 1 is 0. And 2 minus 1 is 1. Okay, and we'll put those points down. Negative 2, negative 1, negative 1, 0, and 2, 1. Now with the absolute value function, you know that those dots connect this way. And you're done. This is the graph of this function using transformations. So let's go name those transformations so we can plot these points, see that change. So from here to here, we added 2. That means we did a horizontal shift left 2 units. So we took this graph and moved it left 2 units, and you can easily see that from the origin, and then down 1. We did a vertical shift down 1. So left 2 and down 1. You can see that the origin landed here. And of course, the whole entire graph is being shifted left 2 units and down 1. And that's what happened. All right, guys. Well, I hope that helped. I have many other videos doing all different types of topics and graphing all different types of functions using transformations and so on and so forth. Again, I hope this helped, and please check out my other videos, and I will see y'all soon. Thanks, guys. Bye.